Okay, this better work. That worked. Good. Aye, that worked. Okay, had sound. Helps if I go in and tell it which audio source to use. I was all set and everything was good. And good evening, everybody. Welcome to DeWitt 3D, or DeWitt. I'm just going by DeWitt now. Oh, shoot. I forgot to bring them. Anyways, that's okay. Good evening, good evening. First thing I want to say is Jerry. Listen, Jerry, I appreciate you being here. I apologize for yesterday. I know I came on, I didn't even say 2 words. But all of a sudden I just felt, I think it was something I ate earlier that day, and I felt like I was going to just let it go right there. So I had to get off. I just wasn't feeling good. I do apologize. I will try and make it on this Saturday though. And I know I just didn't want to be rude and leave, but at the same time, I felt if I talked, it wouldn't have been pretty. So anyways, I do apologize for that yesterday, Jerry. So I did try to make an effort to get on there, even though I wasn't feeling good. So much better today. I just think it was something I ate. So let's see who's here. Who was here first? Another CG is here. And it's funny you said that, another CG, because I was opening the Fusion document that I was going to show you guys tonight, but it said I can't open it here because it was created in a newer version of Fusion. No, I'm not, Matt. Yeah. No, Matt, I'm not. Unfortunately, no, I mean, fortunately, I'm not. But another CG, yeah. And so it wouldn't let me open it because I didn't realize that I hadn't updated my Fusion here, but I had updated my Fusion at the office, so I had to go through the update process in Fusion here in order to open that document tonight. So there we go. You get the stent tomorrow. Oh, Jerry, listen, I'm going to be praying for you, my friend. From what I've heard and what everybody was saying yesterday, I think it's going to be a pretty standard procedure. So you're going to be in my thoughts and prayers, my friend, for sure. Okay, and I know it's going to go well. You're a strong young man, so you'll rock this, definitely. And okay, so Jerry is here, of course. Wiki Central is here. Let's see who else. Betty Boop is here. Hello, Betty Boop. William Nelson is here. Guy the Jedi. David Walton. Who else did I miss? Kenneth Davis. Matt German. Hey, Matt. Not very often I see you on my stream. I'm glad you were able to join us for a little bit tonight, or however long you're going to be here. Tuxedo is here. And I think that's it so far, that everybody that's talked up, and we have 18 people. Go ahead and enter the draw for the Polymaker tonight. It's pinned at the top of the chat, or it's in the description. The draw is open, so please go ahead and enter that. I have brought the Polymaker draw music back due to popular demand, okay? And I've also brought the Super Chat music back due to no, there was no popular demand for Super Chat music, but I have brought the Super Chat music back too, so there's only one way to hear the Super Chat music, and I don't like asking for Super Chats, but there's only one way to hear that music. But we did bring the Polymaker draw music back in, just because popular demand. So the Mad Owl is here. Hello, good evening, and happy Sunday to you too. And who else? Yet another Dan. Yes, another Dan is here. Yes, I think, and you were one of the ones that wanted the Polymaker music back, so there we go. We listen. Tulsa Skin is here too. Klondike is here. Man, you guys are popping in like flies on food. Like, come on, this is cool. This is cool. And yeah, wow, look at that. Look at this. Which one of my chats here is slower than the other? I think this one's a little slower than, no, this one's faster because John just popped in. John John just popped in. I never claimed to be good with last names. Anyways, we got some stuff to show you tonight. I was going to switch gears. I'm printing another flashlight as we speak on the Centuri Carbon here, another one of these. I'm printing the body in this really cool Fiberon ASA CF08 reinforced ASA carbon fiber and printing it in the dark red. It's going to look really nice. I love that dark red color in that. So I'm doing another flashlight in that dark color red. So we're going to build that. We smelled the DeWitt funk. You smelled the DeWitt funk. There we go. And who else? Deanna the Baker is here. Hello, Deanna the Baker. Welcome, welcome. Are you baking while you watch tonight again? So, hey, you never know. Okay, so the design challenge I have. Now, I've kind of, as you know, when we design, you may or may not know, I am far from the, how do I want to say this? I know enough about Fusion. You thought it was next Friday. Oh, Klondike's talking about that. Okay, about Jerry stint. So, but everybody just, open prayers and thoughts for Jerry, who's getting a stint put in tomorrow. So let's just keep Jerry in our hearts and our minds, everybody. So, exactly another CG. I know enough about Fusion to be dangerous. I can work my way around it, but there are certain things when I come up and I scratch my head and I go, man, how the heck do I do this? I'm learning more and more each day because I commit myself to watching 3 to 4 Fusion tutorials a week, if not more. And there's a few people out there. There's one called Send to Print. I don't know if anybody has heard of her. And I learned some amazing tricks from her YouTube videos. It's called Send to Print. You can look that up on YouTube. Basically, I follow along with the design, and at the end of the video, she always says, okay, let's send to print, and shows us what was done. But I've learned so much from that. I just can't really name off the top of my head the names of some of the channels that I do watch that I learn a fair bit with Fusion. So, and the tips and tricks are amazing. If you find somebody that you like and you like the way they teach, then just go ahead and watch them and learn from them because there's so much to learn. Fusion is a complex beast, but let me show you the challenge I had. We have a few people here now. Let me show you the challenge I had and what it's for. I think I've showed you guys or talked a little bit about what I've been doing in the past for this machine that we have, but I want to show you exactly what it's for. Hey, Rajdi. Hello, hello. Okay, so let me switch over to the Fusion window. Let me open Fusion here, boom, and switch over to the display. And I think you're on the display now. I should be able to see what you're seeing. I'm gonna, just give me 1 second, I'm gonna try something here. If I go like this, that is not opening for some reason. Oh, maybe now, if I go boom, there we go. Send to print on the list. Send to print, yeah, send to print. Send to print is the one. Okay, so you guys can see my Fusion screen right now, I assume. I assume you can see it. I'm going to assume you can see it because I can see it, and I've got it on screen here. So, okay, so here is the first two. So I've done a few versions of this. There's one version right here I did of this thing. We're going to show you another version. Oh, first of all, let's go back. Let's go back to me here for a minute. I forgot. I'm going to show you exactly what this is about. So we have a machine at the office. Excuse me. We have a machine that's blinding. Good one. Yeah, I don't use dark mode in Fusion. I do at the office. I should switch it to dark mode here because I'm so used to getting in dark mode now. But anyways, we have a machine at our office that basically we No,
Polymaker
no,
giveaway!
no.
All the
If I go one, I'm so confused here. The video is not frozen. The video is not frozen. See, I'm here. See? So the video is not frozen. So I was just showing you, this is a business card that I went in and did a quick design on. Okay, so no audio when I switch over, but you can hear audio now. That's weird. Okay, no worries. What I'm going to show you is that I ran a sheet of business cards. I'm so confused. What's going on? Is the audio now? Is there audio now? Yes, tell me there is. It's only about a 3-second lag, so just somebody say yes, you can hear me. Dominic Versetto, it always airs at 7 p.m. Eastern Standard Time. Okay, one Raz, hello, hello. So 5 o'clock Mountain Standard Time on Sundays, yes. So, okay, what I'm going to show you is I did up a sheet of business cards for myself for my new Duet logo. And I'm going to show you the machine cutting the business cards. Now, because I won't be able to talk during obviously showing you this video because the audio is cutting out, what's going to happen is you're going to see it's going to go through this machine. I've propped the lid open and overridden the safety just so I could get a good video of it. I know, shame on, shouldn't override safeties, but hey, that's me. I like a risk. And it's not like I'm going to slice my fingers off. Trust me, I don't stick my hand in operating machinery usually, unless I'm drinking. But you're going to see the business cards go through. They're going to be sliced. So there's slitters that are going to slit it. And then there's a guillotine that comes down and it slices into the 2-inch lengths. In between each card, there's about a 1/4-inch piece of waste, okay? And you'll see when I play the video, what happens to these 1/4-inch sheets of waste is they're supposed to drop down into the waste bin, okay? But there's a flaw in this machine, a fundamental flaw that they have fixed in the newer versions of the machines. We purchased this machine as a used product, refurbished used machine. It's in great shape, but it does have, this is one of a couple flaws. This is the major one that they did fix, in the newer machines, but they did not offer that retrofit for the previously built machines, which is why I'm offering a retrofit for myself here. And the retrofit is that they have a fan that blows down towards the cutter, which actually forces those offcuts or assists those offcuts into blowing down into the waste bin. What's happening without this air assist that's going on is those offcuts will stay there, and the next sheet, there's a possibility that the next sheet can drag those offcuts through, can interfere with the cutter, and or they get sort of stuck at the output, and the machine comes up saying there's a paper jam at the feed end of the machine, which there's not. It's just a little offcut that has been dragged through too. So, well, exactly, another CG. So what I'm trying to come up with is an air blade, if you want to call it that, that's going to blow those offcuts down into the machine. I had a few challenges as far as designing it, getting the airflow to the pressure it needs to be, et cetera, et cetera. It's still a work in progress, but I'm committed to finishing this. Number one, because I want my machine to run well. Number two, the company that I bought the machine off of, it's a company called brain fart, Scandicor out of Saskatchewan. They have about between 11 and 15 customers that have this same machine that are very interested in purchasing a retrofit if I can get this to work. So I am committed to get this to work because I can make some profit on this if I can get this to work the way I think I'm going to get it to work, and I'm very close. So Let me show you the video now after I've explained what it is that we're trying to fix, and then we'll come back after I show you the video of the machine. So here we go. So the first thing I'm going to show you is the cards. We run them 24 up, and then I'll show you the video of the machine cutting them, and then I'm going to show you the error message I get and where the scrap paper gets stuck on the end when the paper pulls it through, and then we're going to come back to this. So just give me a minute, just a couple seconds here. So here we go. So hopefully that kind of gave you an idea of what happened. So as the first sheet went through, you get those little offcuts, okay? It doesn't happen all the time, but then the second sheet went through, it actually finished the cutting, but then that error message came up, and as you saw at the end, with the tweezers, I pulled out that little offcut that had got dragged through. So the idea is to get a blower in there so that you can't blow through the sheet, so it's not like I'm trying to blow down each cut, but after the sheet passes through, then the air is going to blow those little pieces that are off cut that are stuck there. It's going to blow them down into the chute so that when the next sheet comes through, it's not going to drag those pieces through. So yeah. Oh, thank you. Nice cards. I just designed those really quick today because I wanted to run some cards through there to show you guys what happened. So my first iteration, I'll show you these. So this was my first iteration, if you want to call it prototype. Let's call it a prototype. I've got the design in there. I won't bother opening it because it's kind of embarrassing, my design on this, but this was my first prototype. As you can see, it was printed very rough. I think I printed it on end like this, or either that or I printed it on the side. I don't remember what was on the bed. I think I printed it like this on the bed, something like this. I didn't account for, on the lid of the machine, there is a little screw that sort of sticks down that I had to account for. I didn't, so I ended up drilling a hole in here, and then the screws that hold the handle on the machine I didn't allow for, so there's a couple holes there. I ended up just hacking these holes out so that I could two-way tape this onto the lid, and then this would shut with the lid, and then the idea was that these blowers would blow the air down into that gap where it needs to be. So I had measured how far in I needed the blowers to be, and and I thought this was going to work. So if we take a little closer look at this, you can see that I put some little air slots in there, Then we had the opening for the fan, the blower fan that I had bought. Now, no, there's no air escaping there because I put a big block in here So the air just flows over here and the air just flows over here to where these nozzles are, and I blocked all airflow down the middle because we don't need, and that has to be down the middle because there's a roller pressure thing in the machine. You could see there that the blower's got to go on either side of that. So this was a pretty hack up job, but it was the very first prototype, okay? So I learned a couple things from this one. Number one, I learned that, hey, you want to make sure you model in these areas here, okay? So, oops. Chat, I didn't catch up with chat. So yeah, so that was the first prototype, if you want to call it that, okay? So this prototype has lived its life. Learned some lessons from it. Prototype number 2, I did some chat GPT stuff. AI kind of helped me. It talked about, I was looking up airflow, and I learned, keep trying to remind yourself to design parts specifically for printing. I'm like, yeah, you know what, is that not the truth or what? And we're going to get to that as well. We're going to get to that. That was one of the other challenges, was designing this to make it easy to print. Anyways, this was iteration number 2. It's much cleaner. One thing I learned, I guess anybody that's into cars would know this. I didn't know this. I needed to build up, because of the type of blower I had, I wasn't getting as much pressure as I wanted to. So one thing I learned from AI was that when I make the nozzles, if you see what I've done here, make a taper so that you have a wider gap going in with the air and a narrower gap coming out. So basically it's a conical shaped blower, which supposedly is going to increase airflow out of the nozzles. This is a full length one. I did this one to try without that one piece we had in the machine, but we do need that piece in the machine. Another one of the machine design flaws, but we're not going to get into that. That's a whole other story. So yeah, I had to end up getting rid of these. I tried it without it, blah, blah, blah. That's for another story. But this second iteration, then I added magnets as well, because I thought, why two-sided tape? Why not just hold it on with magnets to the top of the lid, which did work, and the blower fit, and I put it in, but it didn't do such a good job. Now there's another fundamental flaw. Another fundamental flaw that I was told in this, again, AI is really cool for things like this. I took a couple of different angle pictures of this thing, uploaded it to ChatGPT and said, tell me how to improve it. One of the first things it said is that you don't want airflow to encounter a 90-degree angle, okay, because that hinders airflow. It said try and get that angle tapered more. You know, again, it gave me the tip about conical, making the nozzles conical shape, okay? And then also it talked about having a larger, what did they call it? A larger shell to allow better airflow movement or something like that. So this one is completely hollow inside to allow full air movement, okay? But again, I was not getting very much pressure out of here, which kind of leads me to my third one, which I tried, okay? So this was one, we had the magnets in it. It was my second prototype. It fit the machine fine with the fan I was using, which I'll show you in a second. And that's another lesson learned, but it just wasn't cutting it, okay? So we can get rid of this one, okay? Brings us to our third model, okay? This one you'll see is a little bit different. Actually, it's a lot different. So you can see on this one that we have gotten rid of the 90-degree angle, okay? We got rid of the 90-degree angle. We got a little bit more conical taper on the nozzles, okay? We made the nozzle holes a little smaller. My thought process was that smaller openings are going to offer more direct airflow pressure on it. Okay, of course, we put the cutout on this. We put the cutout back. We made the middle solid again so that we were just getting airflow. Actually, we made the middle solid. It's hard to see on this camera, but maybe on the overhead camera here. Let me just check the overhead camera here. There we go. So we made the middle, so you can kind of see where on this side here, if I hit it right there, you can kind of see I've put infill in there and infill in here. So all that's getting air is here and then over here and over here, so there's no airflow being wasted here. So the air is being forced down both sides of this from the middle where the input is here. Okay. More pressure, but also more restriction. Exactly. So now what happened, the fan I was using, here's where we're getting into another interesting lesson I learned. The fan I was using, and I learned a lesson, and you guys, you engineering type out there probably know this already. Let me just get this, let me just get something out of the way here. And we're going to show a lesson, another valuable lesson. And it was an eye-opener for me too. Okay. Let's back to here. Oh, wrong one, and we'll cut back to here. So, my P-brain, let me unplug this, plug this in. So I thought, you know what? All I need, long slit would be better than nozzles. Well, there's where I'm going to be asking you guys the questions, but you're getting ahead of me here, Jerry. That's okay. So I thought, I want more pressure out of these nozzles, okay? I thought, I want a fan with a high CFM, right? I want a blower high CFM. So we have this nice, I think this is a, what size this is? This is like it's 80 by 80 or 60 by 60. Doesn't matter, it's a big blower, okay? Here, let's go back to this one. So this is the blower I got, okay? If I then go ahead and plug this blower in, which I just did, and we'll plug this in, and we have a variable speed switch for the blower, which is cool. Okay, I'm gonna cut back here so you can see it blow my hair. And then I turn this on, full speed. It is blowing a relatively decent amount of air out of there. See, you can hear that, okay? So it's blowing a pretty good decent amount of air out of there. But with this, put this in the piece. No leakage here, but you know what? Very, very little air coming out of here. Okay? Questionable choices, you're getting ahead of me again. I am getting a lot of air loss right here because this has encountered resistance. This blower is giving me tons of air loss right here. I've got good pressure coming out of the back of this right here. I got hardly anything coming out of here. Boom, right? So, yeah, but if this is not under any pressure, the air coming out of here is fantastic with very little to zero leakage out of here, all coming out of here. The moment I put any resistance on here, I lose all the air, okay? You guys know this. A lot of you guys know this, but this was brand new learning experience for me. So, questionable choices just kind of gave it away. I've now learned the difference between CFM and static pressure. Okay, again, by utilizing AI. Use a compressor and solenoid with a sensor. Okay. It was suggested to me that I possibly get a compressor, but a compressor is expensive. And you can get a lot of pressure out of a compressor, but I thought, you know what, let's explore this static, I think it's called static pressure versus CFM. And so this was okay, but again, it failed. Which brings us to where I'm at now. Well, first of all, let's look at this. Okay, this is a fan that I picked up. There was another. Oh no, this is it. So you look at this fan that I got, and you're going to say, "Wow, that's a small fan compared to what you just had. That's not going to be nearly as good." Well, yeah, it is. This is a higher static pressure fan. This has, if I'm not mistaken, 6,000 PA, I think they call it, which I don't know exactly what that means. But ChatGPT suggested I get a 2,000 to 4,000 PA static pressure fan. This fan does 6,000 PA or 60 kPa, 60 kilopascals per something, pascals, okay? CPAP fan. Again, I don't know if a CPAP fan is going to have the pressure, the static pressure I need. I don't know. used in PCs all the time to achieve better cooling. Pascals is a unit of pressure. Okay, so this has 60 kilopascals or 6,000 PAs, pascals, okay, because kilo is 1,000, right? Open the small holes to a larger hole on output, which is what I'm, there's the little, okay, so anyways, let's, I digress. So got this fan. Obviously that fan's not going to fit the large opening I had. And then I also had the design challenge too, because the other ones I was printing vertical like this, okay? I was printing the other ones vertical like this. Because I don't have these nozzles, just because it's on a 45-degree angle, I had to support underneath each one of these nozzles, okay? And because I had that big hunking thing sticking out, I had to support under that. And I couldn't really print it this way. I couldn't really print it this way. I couldn't, but I had to print it like this. So we had one flat surface on the bed, use the supports that are coming all the way up, and it was just a support nightmare. Okay, so then I thought, well, I got this little fan with a little opening. Why don't I just give this just a little opening on top and keep a flat surface here? Okay, ignore the fact that it's an ugly print, because that's, and then I thought, then I can print it just like this. Boom, then I can print it, flat surface on the bed, put a few supports for this angle coming up here, because it's not quite a direct 45-degree angle coming up, okay? Then I don't have to support these nozzles because they're printing no problem. The challenge in this was the inside of this, the cavity, needed something to support it inside. Otherwise, we're having a massively long bridge, which is going to happen, which is not going to work so well, okay? So I'll show you what we did to get to that. So let's get back over to that Fusion document now that I've kind of explained everything to you, okay? Hopefully this isn't boring, everybody. If it is, just stick around for the draw, enter the draw, and that's okay. But, you know, you're called a captive audience. If you want to win, you got to be here. And if you got to be here, you may as well listen to me. So here we go. But hopefully some people are getting something out of this. So at least I am. So, okay. So let's go back over to the Fusion document now. Let's pop this up. Let's go to the display. There we go. So I'm not going to dwell on these ones here, or this one here. Those are my old designs. Let's open the one that I just recently did. And again, you're going to cringe possibly at the, if you see the bottom, my design timeline here of all the steps I took to get to this point. Because a lot of times it's like, oh, I can do this back here, or oh, I got to do this, or oh, I got to add this to this sketch or that sketch. But I basically, there we go. My Space Mouse was not responding. But I basically winged this as I went. A lot of it was pretty standard. I mean, the whole thing started, the initial sketch started with a sketch that looked just like that. Okay, so we had that that curvature, so we didn't run into a 90-degree angle. You're getting some things, cool. So, you know, we didn't have to worry about that 90-degree angle, et cetera, et cetera. Okay, so that's sort of where the first sketch started. So if I drag back along this timeline, right back to the very beginning, it'll kind of show you the steps I took. So we got our basic shape. Okay, then we had another sketch. Oops. Oh, let's go back to this one sketch. Actually, it's easier if I turn the sketches on, and then you can kind of see where we're at. So then the other sketch was to sketch the two holes we needed, okay? We need our input hole for the fan, and then we needed that other hole, which is for the top part of the machine that's going to have a little screw that has to stick down in there for when I mount it, unless I change where I'm going to mount things. And then we added another sketch. What did we add on this other sketch? I don't know why I added that sketch. And then we did some extrusions. Okay, oh, to cut those corners, because I wanted to cut the corners to minimize the plastic use in this and minimize any air wastage inside it. And then we went ahead and we did shell. We shelled it out. So if I show you the analysis, we shelled everything out. Okay, just like so. Okay, and then we did another extrusion. Okay, which means we got rid of the hole for the fan. We cut the hole for the fan, and I added another sketch for some reason. I don't remember why I added this sketch. But anyways, so there may be some stuff in here I didn't need. Then we did an offset plane. We did another sketch. Oh, I didn't turn the sketches on, that's why. Let's turn all these sketches on. Oh, so we sketched our nozzle, okay? And then of course we did an offset plane to get the tip of the nozzle because we were going to do a conical nozzle. Then we created our loft. And then we extruded our loft. Am I missing some bodies here? No, I'm not missing any bodies here. Oh, I guess if I do the, take the analysis off, you can see where I put the nozzle there. And then we just did a rectangular pattern to get all the nozzles in line and spaced out evenly. Okay. If I move along, anyways, let's just move right to the end here. So anyways, this is what the final product ended up looking like. I'll turn the sketches off. So if we look inside, what I ended up actually doing inside was, in order to give me some support, so I didn't have to worry about support inside the body of this, what I did was, if I can find the correct sketch right there, I went ahead and added some ribs, if you want to call them, every so often. Right in the middle there is where the input for the air input goes. So I added a whole bunch of these so that I just had short bridges to go across these. And of course the airflow is going to miss these altogether because those are going to close right up. So if I go ahead and edit this sectional view, you'll see that basically it's going to print all the way up. Okay, there's my input for the nozzle. There's where that little screw goes in that's just closed right off. And that way, as I print it, it's just going to bridge over those things nicely without sagging. And boom, then you got your finished model, okay? So, and then it prints, of course, this way, upside down, so that when you actually print the job, you can see as it goes layer by layer, it doesn't need any support, any additional support other than perhaps on the outside of this curvature here. Okay, so that's kind of how I designed this final piece. Let's go ahead and turn off my construction planes and my origin planes. Yeah, so that's kind of how I did these. So there's the look at that. Then we have the inside where the nozzles are. Okay, so inside where the nozzles are, we basically put some nice smooth edges on there so that the air was just, you know, would flow down. So the air flows from up here in the middle here, right down, and hits all the nozzles from one side to the other. So that's kind of how I designed this so that we could print it that way and have zero support, other than I realize that I do need some support along this curvature here a little bit, which is nothing. It's real easy to do, okay? So with that done, the only other thing that I need to do on this is now I have to figure out a way to attach this to the machine. And I'm thinking to attach this to the machine, I just need to put a couple strips of, perhaps create a couple strips from here and out and here and out and have magnets so that it attaches magnetically to the top of the machine. Something like that. But again, this is sort of the design challenge that I was facing. Number one, to get it to print without supports. Number two, to maximize the airflow. And number three, how I'm going to mount it to the machine. So there we go. That's kind of what I've been working on. 98 on peak next week. Crazy Cali. We're warming up next week. It's supposed to be winter here. We're supposed to be getting in the high teens for temperature Celsius. So anyways, so now we've got this piece. Let me go to the overhead. Then I realize when I get this piece home, and this is, I printed this without support. You'll kind of see if I go here and here, you'll see that it's not the cleanest of edges right along here. That's where I'm going to need to put a little extra support. I just printed it without support to see how it would do. And I just need to put a little bit of support material just along this edge until it gets up to the point where it's going to be able to print nice and clean. But that's okay, that's cosmetic. On a final print, if I'm going to sell these, yes, I want that to look good. But as a prototype and a test piece, I don't care what it looks like as long as it's airtight. Okay, so that's all. That's sort of what that's about there. Would have better airflow if the nozzle was on the side versus the top. Would be more direct and give more CFMs. Now it's funny you say that, Indie Nation, because what are these? I got to get these notifications out of the way. They're blocking my chat here. Because that's another thing that I was going to, that curve can be straight on the outside. Yeah, well, let me get to the first point. So the issue that I ran into was that the fan opening here I thought would just slide nicely into the hole. But turns out that the base of the fan is almost in line with the screw that's holding the fan together here, right here. And so it doesn't quite work. So shallow curves are going to be ugly even with support. Yes. So I just quickly modeled up a quick thing here out of TPU. This fits on there nice and snug, and this fits in here nice and snug. So that's basically it. Now, who mentioned it? The fan. Then I thought, can I somehow mount this fan inside on the side here so that everything is enclosed in the printer, so I don't have anything stick in the cutter, so I don't have anything sticking up where the glass should be, and I don't have to, cut out the acrylic for that cover to allow for this. Could this be inside something like this? I could make this a little deeper. I don't think it would affect airflow, or inside right like this. Is it possible? That's another thing I consider. But what I want to say is that when I put this in here like so, okay, and then let's go ahead and plug my bench power in here again. Okay, we're going to get the bench power going here. Now, and I got this on Amazon, and it's got its own little control board, okay, and we have our own little speed thing here. It runs on 24 volts, okay. It's a 24 volt fan with its own little control board and its speed control here. And obviously we have our black and red power source, and then we have a few other wires which I'm going to assume are for when you hook this up to a computer or a 3D printer. They're going to be the switching wire so that when you turn your printer on, or when it, it's going to say, okay, turn the fan on. We don't need those for this particular case because we're going to have a switch here, and this is going to go directly into this. So if I hook up my bench power supply at 24 volts, I found that so far this is the best design for minimalistic profile, but I think I need to make these holes bigger or make a slot, like somebody said, make two thin slots. Would I get more air pressure? I don't know. So let's go ahead. If I turn the bench power on, now when I turn this on, full blast, it's going to be loud, a little bit. There is no air escaping from this at all, and I'm getting decent pressure out of these nozzles. Do I have a piece of paper here? Hang on. So if I put a piece of paper down here, you'll see that I'm getting, hang on, I'm getting really decent air pressure. So here, can I make that float? Anyways, trust me, I'm getting more air pressure out of this, out of these nozzles. Right here, you can see that there now, okay? I'm getting decent air pressure out of this. And that may be, there we go. See, you can see it's, whoops, fan just popped out. So it's good, it's good pressure. Hang on, let's put this back in. There we go. I would obviously clamp this on. But yeah, I got much better pressure out of this with this fan that has higher static pascals than the other one. So, okay, so let's shut that off for now. Okay. Don't ever have your little clips around when there's a lot of magnets around, because the clips tend to be attracted to the magnets. So anyway, so that is the best I've had so far. I could probably make these holes a little bit bigger, or do you think if I made little slits, like 2 little slits here and maybe 2 little slits here, am I going to get a more even, consistent pressure? Or is this giving me more pressure out of the nozzles, which would force more pressure onto the paper offcuts to blow them down? How many watts? The more CFMs, the higher velocity of airflow. But not necessarily. Well, yes and no, because this fan, this big thing, has more CFMs than this little one, as far as I think I read the specs to it. But this has better static pressure. So basically meaning when the pressure backs up on this, I'm not losing any air. It's forcing the air out any orifices, can't believe I'm using that word on my stream, that it can find. Versus this one, when it meets any resistance, it loses air. I lose air out of the fan itself. Let's get this right out of the way. I don't need that anymore for my demo. So you think slits would be good. It has better static pressure because the enclosure is airtight. And it also gives me, maybe it does have more CFMs, but man, this gives a lot of air out of it for such a little fan. Okay, so that's sort of the so there's 2 more challenges that I'm up against. I have no problem using a little TPU adapter to fit in whatever hole I need to fit this fan in. That's fine. That's what those little pipe clamps are for, to hold them on. Now the questions I have are, should I try and adapt this to fit this inside the machine so that the airflow is basically straight on instead of down, because this is going in and then forcing the air to then spread out. It's hitting the bottom, forcing the air to spread out, whereas if I went straight in, it's just going to basically blow the air straight through. The static pressure is going to build up either way, but am I going to get a little better pressure by not having that 90-degree turn in the top? And I guess I could always just do a prototype with slits, and this basically, I can just measure the pressure with my hand. This I think would work, but if I can get even better pressure, that would be even better. So long as I have room, I can make this a little bit thicker and make the room. I don't think that's going to affect too much of the airflow. Well, mind you, yeah, if I make this 2 or 3 millimeters thicker, but keep in mind, I'm not blowing any air into these cavities here. As a matter of fact, maybe that's a third design question. Let me grab a pen for you, because this will be easier for me to sort of demonstrate with a marker. I'm thinking, let's go to the overhead camera. Better sales all in one unit by integrating the fan into piece. Yes, exactly. Exactly. So the other thing, so if I were to integrate the fan into here, okay, into this center part where the airflow is, I could also design this. So theoretically, right now, and this is just a guess until I see the model, right now, there is no airflow. Okay, right there. You can see where I drew the lines. There's no airflow in these pockets. Those are all blocked off by those supports that are inside. So theoretically, and this just comes down to how I can mount it to the machine. Theoretically, I can eliminate, I don't want an update. Tell me another time. There we go. Theoretically, I can eliminate this hunk here and this hunk here and just have like a T-shaped unit with this fan being attached on the inside here. And then the air just basically comes in here. Actually, what I would do, I think what I would do to keep the airflow better is I would actually angle, I would put a curve here. It's hard to write on this plastic. And then put a curve here, okay, to get the airflow. So in and in, so the airflow comes down into both sides. That eliminates all this plastic right here. I could still print it flat down on the one side, just have some supports, a few different supports on the outside. So yeah, 2 large fillets, exactly. Fillet of fish, too large. Oh, you mean fillet? Oh, okay. I'm thinking food, fillet of fish. So yeah, that way I eliminate all this plastic. I eliminate all this plastic. I get the airflow going straight in here, and it shoots it straight in and then distributes it down. I think that may be the next thing to try. What do you guys think? Do you think? Be careful of your structural integrity from that wasted area. Yeah, well, exactly, right? Like right now, this is strong. Okay. I mean, even for, and you know, that is a great, Chris, that is a great thing to point out. I could even just make it go a little wider, go a little wider, and go a little wider. Okay. And then I've got some structural integrity right here. Okay. And we're still going to have some inside supports here. Okay. And then we still have some strength here, but I do think it's a good idea to keep this fan back here. As one of you just said, keep it as a one-piece unit. Now, I think that may be the way to look at it. Now, I may have to restart the design from scratch, which is fine. You know, I've gotten pretty decent at getting fusion, getting this done. So, but I could probably recycle some of what I've done on this one. So, several years ago, I found an online system to circulate air through ducts. I'm just reading the chats here. You could upload your model and it would do the maths. Ah. It's pronounced fillets. I call them fillets. Yeah. Dual fans integrated in each of those wasted areas for double the flow and direct flow to each set of jet slits if you go that route. Oh. That's not a bad idea either, Barton Fink. So what you're saying is eliminate the middle fan. Possibly we could even have a gap here, which would eliminate, but we need some structural integrity here to keep this piece in the machine. But you're saying basically, okay, have some air blockage down all the way here to where this fan is, and have some air blockage down here. So basically we lose no air in the middle, and you're saying have a fan here, like on the end here, and a fan here. So we have one fan dedicated blowing air in this set of nozzles, and one fan dedicated here to blowing air in this set of nozzles. That's an interesting thought too. Rounding the corner improves airflow and getting rid of the turbulence you'd get at the edges of the corners. Yeah, exactly. Well, yeah, so I rounded as much of this as I could. If you saw the first ones, we had too many corners, I agree. But there's a couple great ideas. There's a couple things to consider. 2 fans, one for each set of blowers. Okay, that way we double the output. That's great, because that way we're not splitting the output of this fan over these 2 sets. And who's to say that it's going in evenly over the 2, because we actually have 6 nozzles here and only 5 nozzles here. So that's interesting. That's really interesting. So, okay, well, there's some food for thought for me to try, you guys. This is great. But yeah, oh, and then onto the fan. So this part's easy. This is a 24-volt fan. For those of you, some people didn't see the machine. I want to show you, for those of you that weren't here, I'm going to show that machine again, and I'm going to show you the issue. I'm going to run this video again. I actually took a video of the machine cutting the cards, and you'll see in the machine, as the cards come through, there's a guillotine that comes down. I call it a guillotine. Some people call it a guillotine. There's a blade that comes down, okay, a super sharp blade, and it slices the cards into the lengths. But in between each card, there's about a 1/4 inch gap, which is called bleed, okay, and it goes chunka chunka, then it goes chunka, and then chunka chunka, and chunka chunka, and those little pieces are what the issue is. Those little pieces, after that last sheet goes through, those little pieces need to be blown down into the collector. And the flaw in the machine is that there's nothing there to blow them down. The newer machines that they made have a built-in blower now, and so they've obviously fixed it, but they did not offer a retrofit for the people with older machines, and there's about a dozen of us in Canada that have the older machines. And the company that sells these used and is servicing these older machines is extremely interested in my progress in this project. So Hence why this needs to be done. It goes bunga bunga. Oh, bunga bunga. Well, you'll hear it in the video. It goes, I don't even know if you hear the video, but you'll see in the video what I mean. But let me roll that video and show you the issue, okay? So for those that didn't see it. So here we go. So the first thing I'll show, these are the cards, then I'll show the video cutting the cards, and then I'll show you where it jams, where we get those little pieces jamming, which is why we need them to be blowing down into the waste collector. So here we go. These are the cards. Yeah, so exactly. So where that, I had that lid open, I had bypassed the safety, but that lid normally comes down and this blower would attach to that lid and come down, and this is angled out just properly so that this blows right down where those scraps were sitting there. And at the end of the last sheet, this blower ideally would blow those scraps down into the waste bin so that the next sheet does not drag them through. That's the issue, and that's why they built these blowers into the newer machines. So, and there, yes, there's limited space. I can, if you notice, there's one piece I'll show you again. And the reason this slit is here is because the second flaw in this machine is that there's a little block in the middle you'll see that this has to go around. That little block is to put a little bit of pressure on the middle of those rollers because what was happening is the middle of those rollers were wearing out a little faster than the end, and the card that goes through the middle wouldn't have the roller pressure and it would skew a little bit and your card's coming out crooked. So they put that roller in so that you could snug down those three rollers that are controlling the output of that final card. The newer machines, they've again made an adapter for that so you don't need that piece. But you'll see that little piece in the video here, right here. So it was that little piece on top, 4 black screws, that would put the pressure on, hence why we need this gap. So really we're only blowing down the sides, okay? If the one in the middle gets stuck, that's a whole other story. I can't really get in there, and yeah, so we are limited as to how far we can go down without touching the rollers, right? So that's why we need as much pressure as possible. So, and then, okay, so then the other thing, this other one I had, that other blower, you had to plug in, you'd have to run your power cord. This one runs off 24 volts. Well, guess what this machine happens to have in it? This machine has 2 power supplies. They look like mean wells, but I don't think they're mean wells. It has 2 of them, And I'm going to be willing to bet my bottom butt that one of them, at least one of them, if not both of them, are outputting 24 volts to either the sensors, to the display, to something. But I'm going to bet that one of those is outputting 24 volts, or I just put a little 24 volt power supply in to hook this up to, okay, and then we 3D print a little enclosure for the control board, which can go in the side of the machine or something, and then we just have a little hole in the top cover for our fan switch. Okay, so you have on the top, you have your fan switch, boom, your fan's on, boom, your fan's off. I'm sure I could even switch it somehow. The electronics in that thing are complicated, as you can imagine. I'm sure I could even switch it somehow so that when you start the machine cutting, the fan kicks in. But for now, just having a switch, a variable speed switch would be plenty. So don't forget to consider other options as well. Example, maybe suction would be better than blowing. There's no way really, if you saw under that machine, sucking is better than blowing sometimes. This is a family-friendly channel. I don't know if that would work. Can you get pics of the blueprint of the newer machine to see how they added the fan? Oh, that's a good question too. I could always reach out to Graphic Wizard and ask them that. Yeah, I suppose I could. That's what she said. Somebody had to do it, didn't you? Yeah. Could your problem be dirty rollers? No. No, it's not. No, those have all been cleaned. I have even tried, so it's sort of hard to describe, but when those pieces get cut, there is a metal plate that sort of sits underneath that whole area, and the offcuts are meant to come down, hit that plate, and slide down into the waste collection, okay? I have even cleaned that metal plate, spotlessly clean. I've tried anti-static spray, because I think some of the issue could be static, that those offcuts are sticking there, static. They're sticking to the rollers mostly though, right? So the anti-static spray, it's an anti-static spray for machinery, for bindery machinery, takes care of the static issue. The rollers, those rollers were brand new replaced, so those rollers, I don't think they're dirty because really nothing comes off of these cards. It's all digital printed cards. There may be a bit of residue that comes off. I could try and clean them, but I think a lot of it's to do with static and the fact that they're grippy rubber rollers. But as I said, the company added a blower to their newer machines, which suggests to me that they not necessarily were not necessarily aware of the problem to begin with. The problem didn't happen to begin with, or there's a much more variety of papers and card stocks that we're running through these machines now. This happens worse with the thicker stocks. Okay, we run 100 pound, 80 pound, 130 pound, 111 pound stock through it. Every one reacts a little bit different, but everyone could use the fix of the fact that we can blow these scrap pieces down. So, yeah. And for those that are here, can you post links? Oh, links, you retracted your message. But for everyone here that didn't see the Fusion document, I'll just show you here as to what I've done, and then I should be able to. So this is the model I did in Fusion. Let me get rid of this thing on the bottom so you can kind of see the steps. So as I said, I started with a simple sketch that looked like this. That was the main design of the thing was just basically, let's get a blower. We wanted the distance from there to be 130 millimeters because that's how far in we need to blow those pieces. And then from that sketch, we basically did everything. We basically did everything else. So a couple things to consider then, obviously, is, let's bring this view here up, is right now the air is blowing straight down here and then down these gaps out to the nozzles. So the thought here, there's the few thoughts we had, was to put the blower on the end here, okay, instead of on the top, or to put dual blowers, block off all this middle section, and put dual blowers, one on this side, one on this side, and we can still keep whatever. Now all these fins here, those are strictly support, so that when, so that as the, and again it prints upside down, but those are strictly support with a 45-degree angle on the ends there, so that when we print it, this top part here as it prints, because it prints this way, so we can just bridge nicely along this top part without having, or we can just, yeah, bridge without having a long bridge, you guys know what I mean. So that's basically right there how this first piece prints. But if we put the blower port on this end instead, that's quite possible that that would work. And then if we go to this other section here, this is another one from the bottom. No, that's not really a sectional view, is it? No. And then here's the other one. Oops. Oh, you know why I didn't cancel that sectional view? That's why. And then if I come into this other one here we go. Let me just show you how this sort of pans out here. So you can kind of see what happens from side to side. So as you see on the top, we're not getting any air going through there until we get to that point right there. Okay, that's just a gap for the hardware on the lid, and that's where the input nozzle goes. It comes in and it blows air down that side, and then it also comes in and blows air down this other side. And again, you're only getting air down this little middle chamber right here until you get the support material in there for printing ability. So yeah, so that's what I'll try. A couple things I'll try is, let's get rid of this analysis. So we'll try blocking off the ends and having the input right here so it blows straight through, or we can put one fan here and one fan here and have blockage in the middle, but maybe I keep the entire profile for easier mounting on the machine. I still have to figure out how we're going to mount that to the machine. So yeah, there's that little mystery too. So basically I'm trying to design an air knife, exactly, an air knife that just blows air down that gap. Yep. Yep. Static was an enormous problem, exactly. Cheap high moisture paper was the worst. Yeah, they sell a static spray for bindery machinery now, and I've got some of that static spray. It works actually quite well. So anyway, so yeah, so those are the challenges still. This is the best setup I've had so far. This fan works extremely well. As I say, this may just work fine, but I want to improve it. But the thing is, these aren't cheap. This was, what was this, $70? Something like that for one of these. And then also, if I do dual fans, I'm going to have dual boards and dual controls unless I can splice them together somehow. But I think what I'll try first is, I think the first thing I'll try is to redesign this with a single fan. Well, no, first thing I'll try is I'm actually going to take this and somehow I'll attach this to the machine. I'm going to take this marked up, messy looking, ugly prototype. I'm going to stick this on the machine. We're going to stick the fan on top. We're going to use our bench power supply to power it. Okay, we're going to stick this on top. We're going to hook our bench power supply up to it on the machine. For those that weren't here when I did this, we're going to clip on the power supply like this. We're going to come up here. We're going to turn this on. And we're going to try it like this, because this has got some pretty good pressure out of each nozzle. Yeah. Oh, yeah. Each nozzle has some pretty good pressure coming out of it. So I'm going to try this and see how this fares. See whether this will work, because this isn't bad. That's the most pressure I've got yet out of all my trials. So we're going to try this, and then from this, then what's the worst I can do? Make it better. So we'll then sort of design this to come on the end like this, so that we can keep it all enclosed in the machine. And we'll try slits instead of nozzles. We'll try the little air slits. I guess, again, I think I would still do a V, but have the slits coming out, because it does make sense like how a carburetor works. The top, you get the conical shape, and that way you get more air in and it forces more pressure out that thin slit instead of just having it like a thin slit all the way down, right? So we have a V slit inside, forcing the air out like an actual air knife. But with limited room, fan on the side would probably fit better, yes. If you continue at an angle towards the nozzles instead of straight side, you would have better airflow. At an angle towards the nozzles. Yeah, the challenge is that we have nozzles on one side, nozzles on the other. And what I was thinking of was coming straight in the middle with curvature, with fillets, with fillet of fish in the sides, okay, so that we just have the air coming out both sides, and then we'll have blockage all the way down the middle, so that we're not wasting any of the air coming down the middle. 2 fans would be great, but I don't know logistically if that's going to work in the machine as far as wiring and how to run all the wires. So, a Venturi effect, exactly. That's what it's called, the Venturi effect. That's what the AI called it. So, yeah. There, 1 fan per nozzle, easy. Yeah. 1 fan per nozzle, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 fans. I think I need a bigger piece. If 1 fan can work, why use 2? Well, exactly, Tuxedo. So that's why I'm going to take this, as pretty as it is. I'm going to probably just throw some VHB tape on it or something, stick it into the lid of the machine, and I'm going to try it. I'm going to actually give it a trial, see if it works. If it works, then we'll go ahead and we will mount the fan on the side. Then we'll experiment with slits versus nozzles. If the nozzles work, great. If the slits can give me more pressure, even greater, right? I would like to stick with 1 fan for the sake of making it easier. Or I could have, as I say, 1 fan per nozzle. 1, 2, 3, 4, 5, 6, 7. Just line up the fans across the, yeah, no. But somebody mentioned earlier, I should try and get the blueprints or try and get the specs of what they actually did to fix it and see how they handled it. So test it, see what happens. Sounds like a poor, the KISS principle of engineering, keep it simple, stupid. Exactly. Bigger slits and print out an insert to try slit versus nozzle. Yes, true. Yeah. Yeah, that wouldn't be loud at all, right? With 12 fans. Who's giving away trade secrets? Where's my chat? Where's my mouse? There we are. 1 fan with 11 outputs. Yeah. Whoops. Proper air gap for the fan inlet also. Yes, I would put the fan inlet, I'd face it down, okay? I'd have it down because across the top is there's an actual, I took it out for now, but there's an actual acrylic cover, clear acrylic cover, so you don't shove your hand in the machine. I don't need it, but there's people out there, you want it. When you have a paid employee running the machine, you want it. So it would go in so that the top of the fan is down, so the wires are coming out here. We'd run the wires. We'd worry about that somehow. Anyways, I'm not worried about the wiring. That can be fixed. And the actual air input would come from underneath, where there's a good probably 5-6 inch gap between the top of the lid and where all the rollers and action happen, so that there's lots of airflow underneath there. So that's how it would go, is that this would be input for the fan facing down, like so. I would definitely have to rewire this because this is way too short for where I'd have to run the power supply. The back of the machine on the far side has 2 big, mean, well-looking power supplies, which I'm hoping have 24 volts coming out of them. So You can also do a flow test in Fusion, but I think you can only do the flow test in Fusion if you have the paid version of Fusion. I think. Yeah, I think so. Nozzles will give more pressure and more direct airflow. True, true. So, and that's why, as I say, I'm going to try this. The only thing I may do with this, although it's hard to say, these holes right now, they're 1.5 millimeter circumference holes. Not circumference, they're 1.5 millimeter wide holes. And I believe they're 5 or 6 millimeter holes coming in the top. So we have that Venturi effect coming out of there. So we'll give this a shot and see. This may be all I need to do this. And if it will give it a good test, and if it works, then hey, then all I got to do is design it so we can put our fan on the back. And then Bob's our uncle. And possibly get rid of some plastic waste on these sides, right? Get rid of a lot of the plastic waste. And then my only challenge is how to mount it into the machine, which it's not really a big challenge. It can be done, right? Like, that's the beauty of 3D printing, is just 3D print anything you need. No, I don't have the paid version. I'm using the hobbyist version of Fusion. Yeah, I can't justify doing a paid version of Fusion. So if you want to try bigger holes, just run a 2 millimeter bit into the tips of these nozzles. Exactly, Barton Fink. Yeah, this is definitely not a final product. This is a prototype. So we try this. If it works, yeah, run a little bit of a drill bit through them. Try it again. If it's better, it's better. If it's worse, we know, right? So there we go. There we go. Okay, are we ready for a draw soon? We're going to do a draw soon. But that's kind of here. Let me, since we have a bit of time, I'm gonna show you the first iteration of this thing I did, the very first iteration, and just to show you the progress of what I came from and what I went to. If I turn that off, so my first iteration was terrible. It looked something like this. You never had an Uncle Bob? I do have an Uncle Bob. Hey, 07UA, hello, hello. So that was my first iteration there, right? So many things wrong. Actually, the first one didn't have the nozzles, but this one does. But 90-degree angle, no good, okay? Way too big an opening up top. The idea was to put magnets in these things. And again, these were cutouts for the, to allow for the hardware that's in the lid of the machine, okay? And, but I believe inside, yeah, and I just had a full open chamber inside with no airflow, no direction, nothing. It was just fully open like that. And it posed a really big printing challenge as well, as you can imagine, because you got to say to yourself, well, the best, how do you print it? You can't print it that way, really, because, you know, you need some support up here, you need some support inside here. You can't print it that way in a sense. Well, you can print it that way, but you don't have very much base, but you need a lot of support. So it ended up printing that way, so that basically we didn't need any support on the edges. We just had to support the inlet, but we still had to support all the nozzles. So that was a ton of support, ton of wasted support. Whereas the new one now, I can print basically, the new one can print just like that with very minimalistic support in it. So, but yeah, this was my first go round, okay? And this had a heck of a lot longer history than the other one did. That I had ended up putting the end ones there to cut those two out, because it turned out I had to leave that gap in the middle there, so that was the full length, and then I just did that to get that gap out of there. Oh, and I didn't even finish. Look at that, I didn't even close the gap in on that one. So that was that one there. So let's just close that. We don't want to save that. This is the one that we're going to end up working with. So yeah, so we think we'll do that. We'll make this thicker. We'll put this top hole on the side. We'll eliminate some plastic on the edges. Okay, but first of all, we're going to test it and make sure, see what happens. But that's the size. Actually, those holes are bigger in the diagram here than they actually printed, because of course there's different tolerances with the filament and so forth, right? So there we go. I don't want the update. I told you another time. Don't bother me. It needed support on the inside. Then how do you remove those? You don't. So for the inside support for these ones, Tuxedo, as you saw here, Yeah, on this one, on the other one, yeah, you couldn't put the support on the inside. This one here, there's my support on the inside right there. Printed this way, and there's all my support right there. So we have minimal bridging going on, right? The biggest bridge was in here, not a big deal. So, yeah. Hey, Mid Madden, hello. Yeah, so this shouldn't be too difficult to actually alter this particular design to bring the airflow to the ends. All I really have to do is in the initial sketch, go enter the draw. We're going to do a draw in about 10 minutes. So go ahead and enter the Polymaker draw. It's pinned to the top of the chat, or it's in the description. Go ahead and enter, and we'll do the draw in about 10 minutes. I think water-soluble support would help, or would you just get a clump of gunk in there? Yeah, no, I don't need support at all. The idea is to do this without support. Oh, Midman. Oh, Jack Faxon. They changed your name. Okay. I won't remember that, but that's okay. Well, hello and welcome. YouTube changed a lot of people's names. So really, all I'd have to do is go back to the initial sketch. And basically, instead of 20, what if I were to make, what if I added, I think if I added 6 more millimeters, what's that going to affect? That would make that a little bit bigger. Okay, so there, we just increased that by 6 millimeters, which really didn't alter the whole design other than enlarge this. And then I will bet that this hole will now fit on the end here, no problem. So let's just say, do I have a construction plane along there I could use? I don't remember what I used for construction planes. No, 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 and no. So, and how big was that hole? Let's see, nozzle holes and top surface. So if I go to that top surface sketch, that hole was 17.2 millimeters with a 2 millimeter. Yeah, I don't really need the 2 millimeter offset there at all, just 17.2 millimeters for that hole. So I do know that I can I sketch on that surface? I suppose I could, couldn't I? No, I can't really sketch on that surface. So I have to do an offset plane, which is fine. So if I construct offset plane from here and bring that out to distance to object, no, it's not going to work either. I have to figure out how to get how I can get a sketch on this surface. I see again, create a tangent plane. Oh, okay. See, I'm still fairly rough and rookie at this. Tangent plane right there. Ah, look at that. That works. Perfect. Look at that. So now if I create a sketch, do I have something? Let me check out my sketches here. I'm pretty sure I do have a middle construction line here. Thank you, Tuxedo. I was going off into a tangent. Now I may have to actually flatten that surface out a little bit for the hole. Well, not really, no, because I can just shove a longer piece of PTFE, or of PTFE, blah, just print a longer piece out of TPU to go in there. So if I sketch on this tangent plane, let's come down back here. Whoa, sometimes I get lost in these things. There we go. So there's my middle right there. So I want to project, let's project that surface, and let's project that midpoint, which is really, I think, all I need to project on that. And I want a 17.2 millimeter. So there's my middle right there. Right there, 17.2 millimeter. 2 millimeter circle. Okay, which is basically in about the right position. I don't really need to worry about, yeah, I'm right, and actually I am right in the middle, square in the middle. I don't think I can get that any closer to the middle if I tried. Yeah. So then all I would do, let me just get me an analysis here real quick. There we go. So then I could take this and extrude this through to here, like that, and there's my inlet. There's my inlet instead of the top one. Deboss my logo and print in 5 color because, of course. There's a good idea, Deanna. So now if I take my analysis off, so there's my new inlet. Okay, that would work. And I don't have to worry really about, see, the other inlet I basically brought down a little bit, which I don't really need to do, because if I just put this on a piece of TPU and I could actually glue it in, that would be fine. So now I just need to get rid of the top one. So if I suppress that, where was that one? I got to learn to label my sketches a whole lot better too. Looks like the Titanic. Let me find that sketch 5. And that sketch is right, where is my, oh, I think that's right here. So if I actually suppress that and suppress that, no, that's not the right ones. Those are not what I wanted to do. I have trouble finding stuff when I do this. Click on the feature and do a find in browser. So if I click on that, oh, there it is right there. It puts 3 little dots above the feature. So I can suppress that, there we go. And then this feature here, this one is right, where's that extrude? That one there. Oy, oy, oy. I'm butchering this. Now, let me undo. Now, let me hide, these sketches are driving me nuts. There we go. That's this one here. Why is it suppressing the one that I just did? It's suppressing this one too. What if I just take that, edit it, and say 0? No, it's not going to let me do that. It gets rid of my other one. Ah. Time trap. Yeah, it's... Okay, let's do this. Let's go back. Let's go back in time. Let's go to this one. Let's suppress this. Obviously, there's something else based on this that I've based on this. Just select and delete the whole. Really? Is that all it takes? So if I... Okay, if I go back to my full select and delete the whole. Oh. Or if I go to the top surface sketch, if I edit the sketch, and if I delete the whole, it comes right back. Oy, oy. This is my inexperience with Fusion, showing full bore right here. Yeah. Yeah, it just doesn't let me just select it and delete it. I can delete the chamfer. No. Yeah, this is, yeah, sometimes you can move the feature along the timeline. Ah. I don't know why I got an error on these two things right now. Anyways, I'm not here to give a Fusion tutorial by any stretch of the imagination. But if I move this feature, yeah, if I move that along the time, I can't move it too far. No, it won't let me move it any further along. But for some reason, if I suppress that feature, obviously I've linked somehow this hole to that hole, and I'm missing a lot of stuff now. Yeah, see, all my stuff inside is missing just because I suppressed this one feature. Look at that. All that stuff went missing. Fusion can be taxing. It's all about where the sketch or the extrude is in the timeline. Yeah, I'll figure it. And again, I think what happens is I tend to do something and then go, oh, I want to add this to it. And then I'll go back to a sketch after I've done a bunch of stuff. I'll add to that sketch instead of just creating a new sketch. And I think I put myself in a bit of a trap here, which I think is what's happening here. So I'll figure it out. I mean, if I have to redesign this model from scratch, hey, I will. It's not a big deal. It's easy to do, and it'll give me the chance to actually probably do it in a more logical order. So, got to respect the timeline. Oh, you do, because hence, this is exactly why you got to respect the timeline. So instead of going back and adding to a sketch that you've already done a bunch of stuff to, just create a new sketch. It's that easy. Create a new sketch, project your previous sketch, and then go on, and you're good. Because I think that's the problem, is I didn't create enough new sketches for some of the things I wanted to do. Okay, let's do a draw. Let's see if we've got any entries in the draw. Let's do a giveaway. 47 entries. Awesome. 47 entries is great. 50 people watching, 47 entries. Here we go. Okay, it's time for, hang on, I got to turn my speakers on because I like this music. Oh, by the way, I fixed all my floor drains. They've all got nice solid printed covers now. Oh, yay! I even designed, oh, let me show you real quick what I designed just for fun. And it was one of the tutorials I watched, and I thought, oh, I can apply this to a floor drain. Hang on. Look at this. This would be fun, and I'm thinking of printing it for my floor drain. Look at that. Nice solid in between, you know. I'm thinking of maybe doing that, and that way it's got drain holes in it, but it just looks really cool. But that's a plug-in for Fusion that I used to get those random shapes in there. And it was just a few clicks and boom, it's done. So I think that's really cool. But you know, if I wanted to make a regular floor drain, I could just go ahead and I could just go back and just make a regular floor drain like I did. But nah, that looks so cool like that. Anyways, I digress. I don't want to save it. No, I don't want to save it. Let's go back down. Here we go. Bug larvae nest. Yeah, there we go. Yeah, Fusion's fun, Jerry. Fusion's pretty fun. Take the time. It's great. There's lots of good tutorials out there. But anyways, let's go to the giveaway, guys.
For the Polymaker giveaway, hey! All the answered names get to play. Hey! Count it down, shout it out, don't be late. Time for the Polymaker giveaway.
Who wants to hear that one more time? Aw, just one more time.
Time for the Polymaker giveaway. Hey! All the answered names get to play. Hey! Count it down, shout it out, don't be late. Time for the Polymaker giveaway.
Yeah, Fusion's fun. I love Fusion. No hexagons. I could do hexagons, but they were too boring. Hexagons were too boring. You should add a spot for 30 minutes of giveaway music. I wonder if that would, I could probably make that a ringtone. Why not? It's just AI generated song I did. Okay, let's go ahead and spin and see what we're going to do here. Ready and spin. Let's see what we're going to do as far as the giveaway goes. Is what fixed? The draw? Of course the draw is fixed. And we are going to, oh, we're not going to land on the fun one that I did. 2 mixes and 15-second spin. 2 mixes and a 15-second spin. I'm just going to go grab the entered names. So give me a moment, oh please, por favor. That's as much French as you'll get from me. Okay, responses are being downloaded. Download responses in a CSV, comma-separated value spreadsheet. And then we move this up there. We open up our downloads. We open the CSV. Dum-dum, da-da-da-dum. Okay, let's see who entered twice. Shall we see if anybody entered twice and is going to get eliminated from the draw? Shall we see? Yes, let's see. Data. We're going to sort the data by username. And we're going to go, okay, let's see. Okay, anybody enter twice? Nobody entered twice. Awesome. I'm proud of you guys. Nobody tried to cheat the system. That's great. Let's shift and select all these names. Let's control and copy these names, or command copy on Mac, which we're not on. And let's bring up the wheel. And oops, come on, open up properly. Here we go. Oh, come on, why aren't you opening up? There we are, and there we are. Aha. Bonus spool since we were good. Oh, I wish. Oh, which reminds me, I didn't get the code yet. Hang on a second. I didn't request the code. I knew I forgot to do something today. Hang on one sec. Hang on 1 second. I've got to go get my code. I forgot to ask for the code. Oh no. Don't worry, it'll get here quick. It'll get here quick. I got to put that in there. I got to put today's date in there and how many spools. I can only do 1 spool without permission of doing more. I'll see if I can do a bonus spool one of these days if you guys are that good. Okay? Okay. You just got your entry in extremis. Okay, so let me get the mail ready that way. Sorry guys, I thought I had done this already, so I'm gonna do this. I'm gonna do the subject is Polymaker giveaway. Undo it, and I'm gonna say congratulations, if I can spell, on winning this evening's draw. Then I'm just going to simply put link and code and my name. Okay. Now we're going to go ahead and get you. And by the time I do this, it'll be here. I guarantee it'll be here by the time I do this. Right there. Paste. And was I right? No, not yet. But the code will be here any second. It'll be here. Okay. Okay, let's do the draw. Then I've got it almost ready to send the winner the information. Okay, let's do that. VB script it next time. What the heck is VB script? What are you guys doing to me? Okay, let's empty the wheel. Control A, delete. Let's paste everybody's name in. Oh, I forget what it was. I think it was 2. Oh, there it is. There's the code. Let me get that code put in the email I'm going to send you first. Then we'll do it. Okay, thank you for the code, Polymaker. And thank you for letting me do this draw. You guys are amazing, as always. And then we got our draft. There's our draft. Why you do this to me, mail? And there's the code. Oh, something's now my mail program's frozen. Come on. Close you. There we go. We got that one. There's the draft. Okay, there it is. Okay, and I can paste the code in now. Now all I need is a winner's name to paste in. So let's enter all the entries here. That's not what I wanted to do. Where'd all the entry names go? Okay, hang on a minute here. Something has gone awry here. Something has gone awry. Download. I have to download the responses again. Sorry guys. You guys know this is not normal. Normally it's more efficient. It goes a lot better than this. Here we go. Can't open 2 workbooks with the same name. I know you can't. That's why I didn't. Okay, close that. And I think that's, okay, good. There we go. Okay. I just got to cut and paste the names again once more. And copy. Okay, this is going to work this time, and we don't need to save that this time. We can close that. We can open up the form, open up the draw thing again here. There we go. This should work. There we go. Here's the names. And I think it was 2 spins and 2 mixes in 15 seconds. And we shuffle 1, 2, and we're going to spin. Good luck, everybody. Do you see my computer disappear? No worries, you can just use my name as a winner. Here we go. Let's spin for. There we go, guys. Good luck, everybody. Yuri's 171. Chris, you won. You won, you won, you won. I will go ahead and email you right now with the code and the link. Congratulations. Where is my code and link now? Congratulations. So here we go. We're going to grab your name. He won the Polymaker giveaway. I'll play that tune once more after. I like that tune. Okay, let's go. Let's find your name. Here we are, and here we are. And I'm just going to grab your email off of here. Where is it here? Let's go here. Where? There we are. And we're going to take this. We're going to go Control C. We're going to close this now. We don't need that open again. Go to my email and go Control V. And send. Okay, Chris, it's on its way to you. You should have it probably, I'm going to guess that to get to the space and back, I'm going to say it's probably going to take 15, 20 seconds to get to outer space and back. So I think you should have it by the time I finish this sentence. You got it already. See? It's fast. I use Canadian satellites. There you go. Congratulations. Congratulations, and thank you for watching, as always. So, okay, another exciting Polymaker draw. Oh, I said I was going to play that song again, didn't I?
For the Polymaker giveaway, hey! All the answered names get to play. Hey! Count it down, shout it out, don't be late. Time for the Polymaker giveaway.
Oh, I like that song. No, you don't want to play it again? And Canadian radio waves. There we go. There we go. Awesome. Well, we're not going to talk about much more tonight, but I can just stick around and shoot the BS if you want. I want to figure this out. I looked up the price of this thing to replace this. These things are almost $400 Canadian to replace this. Okay? I do not want to spend $400 to replace this thing. Chris, can you build me one of these? It's royalty free, yeah. Yeah, for those of you that didn't see this, here, I'm just gonna, this is a battery pack from a company called Ego. This was an Ego 56 volt battery pack for my lawnmower. It decided one day that it didn't want to charge, or to give me an error. It decided to give me an error. I don't think you can bring, no. And so I thought, I'll open it up and see. I'm getting voltage out of it. But if I push this, red light is no good. That red light flashing basically means, oh, you're screwed. This contains 18650 batteries. Let's see, these batteries are 18650, 2 amp hours, 7.2 volts. There has to be at least, oh gosh, 1, 2, 3, 4, 5, 6, 7, 10. There had to be at least 40 of them in here. At least 40 of them in here. it was suggested that maybe one of these batteries is dead or faulty. So, you know what they say about letting your ego get in the way. You might have one or more defective cells. Yeah. So the only way that, as far as I know, and this is me not knowing much, the only way to test, as far as I know, the defective cells is pop them out and test them one at a time. What I don't get, I don't know how low a battery has to get before it's not chargeable. Okay, I don't know enough about this. But I'm getting, off of these, I am getting a voltage reading of 51.1 volts. 51 volts. It is a 56 volt battery. Yes, it's down to 51 because I used it and it stopped working. So I brought it in to charge it, got the error. So, can you measure each cell? That's what I don't know. That's what I can't get in to each individual cell. The way this thing is made, here, I'll switch to this guy. The way this thing is made, if you look, these things are basically capped off at the top, okay? They've got a whole bunch of these little thin yellow wires running down, which I'm not sure what they're for, all the way down the middle. It's capped off at the top, capped off in the middle, capped off at the bottom, so I can't get to the top and bottoms of individual batteries. 51 volts sounds good. You have to disassemble it and check each cell individually, I'm afraid. Yeah, that's you're afraid. You're afraid. I'm the one that's got to do it. So, and then they put all this gunk, they put all this, like, whatever gunk in here. They make this so it's very, very difficult. There's no screws to, or is there screws? Well, maybe that is a screw used to, I guess there is a screw right there I could use to disassemble this. Is there a, no, I can touch those, I don't get a shock. I don't know much about batteries. I don't want to give myself a shock. It's only 56 volts. I guess it's not overly concerning. Still need to look up vids on YouTube and get it to trickle. Oh, that's right. Here, let's have a look. Let's do that while let's look up on YouTube and see if there's a way to get this before I were to decide to take it apart. I forgot about, you had mentioned that last time, yeah. It can be disassembled, no problem, but let's do a little quick on YouTube since you guys are here. Better yet, let's Google. Let's go to Google and let's just say Ego 56 volt battery not charging, error, red light. Let's see what AI says. Red flashing indicates error caused by overheating, deep discharge, or battery management system fault. Fixes include resetting the battery, pressing the button 3 times, holding 7 to 10 seconds on the third, letting it cool, warm up, or tapping it firmly. If the red light persists, the battery may be defective or need a manual BMS jump start. Manual BMS jump start. Okay, let's take that, copy, because I've tried those other things. And let's paste manual BSM jump start, Ego 56 volt battery. Let's see what that does. Okay, to wake a sleeping or dead Ego battery, try a hard reset. First press the fuel gauge button 3 times, holding it for 7 seconds on the third press. If it fails, jump start it by parallel connecting its terminals to a working Ego battery for 2 to 5 minutes. Huh. I wonder. Tapping it firmly. Okay, so let's do the tap firmly. Let's do the tap thing. Okay, here. Let's do the tap thing. Oh, 3 times. 1, 2, 3. And we'll hold it for 7 to 10 seconds. We get a flashing red again. Oh, now we got flashing red and green. Now what do we got? Still flashing red. Oh, we had a flashing red and green. Here, let's try that again. Here, let's try that again. So we have flashing red still. So let's go ahead and hold it. So it said three times, hold it on the third. 1, 2, and hold it on the third. It's flashing red, as you can see. Then it's going to start flashing red and green. So it's about 7 to 10 seconds. There we go. Look at that. Let's just keep holding it longer. Red and green. And then let go. And then we just get the flashing red again. Yep. Okay, so that's obviously not the answer. That didn't work. Okay, because then now, still we have the red. Okay. So then it says, locate the battery indicator button on the back of the battery. Press the button 3 times. That's what we did. The LED should flash. Yes, it did. Indicating a BMS is resetting. Immediately place the battery on an Ego charger. The video demonstrates how to perform a hard reset. Let's look at the video. Just the Yeah, but see, mine didn't go green. Yep, no, not going to work that way. Yeah, no, okay. Okay. AI said it's 14 cells equivalent, 14 times 3.7, 51, 8 volt nominal and 14 by 4, 56 volt charged. There's no more, oh, there's more than 14 cells in this thing. So let's just do this again. Let's just 1, 2, 3. Maybe if I keep holding it till it turns solid green. No. It's obviously not going to do anything. It's obviously the BMS is, something's going on. Okay, so I think based on what it said here, I'm going to clean the contacts, blah, blah, blah. So here it said, I will try. I do have another Ego battery that's working. If this fails, jumpstart it by parallel connecting its terminals to a working Ego battery, plus, plus, and minus, minus, for 2 to 5 minutes. So I can try that. I just need a pair of clips to connect the batteries together. Means I may have to figure out a fix around that. But yeah, okay, well, you know, BMS wake up, these are all going to tell me the same things. What's this one telling me? Let's just see for fun what this one's telling me. Okay, let's watch this one for a second. Because that's what mine's doing, is a red light. No. Yeah, right, like that's exactly what mine does, right there. Okay, let's see what he does. It's not fully charged though, that's the problem. Okay. What? Drop the battery. You know, drop the battery on the ground. That'll show it. Jeez. Drop the battery. So, okay. Well, I'll grab my other ego. I'll grab my other ego, and we'll try the trickle charge from it. But I'm not going to take a $400 battery that could possibly be fixed. I'm not going to take it and drop it on the ground. I'm sorry. Yeah, no kidding. The Fonzie method. I will. I will go ahead and take the. What I'll do is, because we know we have here the positive and minus terminals here, and the middle ones are just, I think, for the BMS or something to do. Anyways, when it charges, but I'll just hook the positive and minus terminals, and we'll hook it up to the working battery I have to give it a bit of a trickle charge. I'll make sure the working battery is fully charged, and then we'll give it a bit of a trickle charge and see if that does the trick. But I don't want to give up on it, because now that I realize how much this battery costs to replace, I'd rather do everything I possibly can to get it going. Easy enough to put back together. It's easy enough. And then worst case scenario, I can pull these apart and check individual cells. Again, instead of spending like $400 on a new battery pack, I'd rather do everything possible in my power to see if I can get it to work. So it is a lawnmower battery. Lawnmower, weed whacker battery. It'll fit my lawnmower or my weed whacker. This one's pretty heavy to go on the weed whacker, but yeah, this is mainly used on the lawnmower. So yeah, it's just a shame because it's obviously out of warranty. It's over 1.5 years old, but it hasn't been charged that many times, and it shouldn't have died. It should not have died. So anyways. You've brought several batteries back by jumping them with another good working one. Okay, well, that's good. So that's just positive, positive, negative, negative. We'll try that, and if that works, bonus. We'll try that this week, and maybe I'll try that live on the stream next week. We'll see. I'll charge my other one fully, and then we'll try it live. Why not, right? What is the A? What is the amp hours? Oh, I don't know. I couldn't tell you. Couldn't tell you. I couldn't tell you. Has it been left in freezing cold for an extended period of time? No. It might have been left out in the fall a little bit, but I take all my batteries in the winter. So, because I know cold will kill it, right? So, Ryobi was lenient with returns for a bit. I had already separated my pack into cells, though. Ah, okay. Do you want another 3D printer? Do I want another 3D printer? Sure. Yeah, sure, I'd love one. Well, not everything. If you don't want, drop on the ground. Huh? How many batteries are they? No, these are 18650s. And they're 2 amp hour, 7.2 volt batteries, and there's gotta be at least, I mean, that I can see on the surface. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's got to be at least 40 altogether in here. At least 40 batteries in here. How they're connected, I don't know. We have these funky little BMS, obviously, wires on the bottom, and there's got to be at least 40 in here, though. This thing's heavy. Like, this thing is really heavy. So they would discharge below the minimum BMS, which was always on. So an 80 amp hour battery pack. Yeah, I think it tells me on the front here. This is, no, this is 6 amp hours. Here, there we are. 56 volt, 6 amp hours. Right there. Yeah, it's a big battery pack. There's the case for it, right? Look at my hand. It's a big pack. And then the back here, nothing on the back as far as information other than, avoid disassembling battery pack. Yeah, of course. But yeah, that when it all goes together, that's a big pack. Yes, absolutely. Yeah. Elegoo Neptune 3 Pro, when I first bought it, was $1,600, but I'm selling it for $700. That's higher than a 50. Wow. But you're probably not in the area that I'm in, so yeah, probably wouldn't work. Shipping would kill me. Bigger than the lawnmower itself. It's a great lawnmower. It's a self-propelled lawnmower, really great lawnmower. I love my lawnmower. Ego made lawnmowers great again. Sorry, couldn't resist. So, anyways, guys, that's it. That's all. Thank you everybody for watching. Maybe I'll do it live on the next stream. I'll charge up the other battery I got, and we'll try and jump these batteries live and see if I can revive this sucker. Why not? Why not? They go for 200 at Micro Center now. There we go. Elegoo Neptune 3 Pro. Oh, no, I don't want one of those. No, 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 no. If I get another printer, my next printer is going to be the, oh gosh, I don't even, it's mind blank. It's the multi-head tool changer one from, I forget it. Anyways, that's going to be my next printer is going to be a tool changer. Okay. Anyways, guys, listen, it's been fun. It's been fun, and I appreciate everybody tonight, and I appreciate y'all watching, and thank you for all the suggestions for my blower. I'm going to modify and alter that blower. We'll test this one and see what we can get, and we'll pick up on this next week, and we'll try and revive this battery next week, so stay tuned. Ooh. Yeah, Snapmaker, that's the one, Tuxedo. Snapmaker's the one that I would get next, if I get one, so yeah. Yep. Index. No, I don't want an index. No. Okay, guys, I will talk to you guys later. Have a wonderful week, and thank you guys for being here, and thank you for all the suggestions. And again, congratulations, Chris, for winning the Polymaker draw, and we'll catch you guys next week. Have a wonderful week. Bye for now, you guys. Take care.